Hello. Ran out of time on that last video, but I do want to go through the solution to this example a little bit more in detail. It's all on the screen right now, but I want to go through each step to make sure that you understood what I did here. Okay, so step one of these problems is to find the slope of the budget constraint, which I did here. So I started up here. The slope of the budget constraint was 2/5. It's actually negative 2/5, but the marginal rate of substitution is also going to turn out to be negative, so sometimes I don't put the negative sign. Anyway, you'll end up getting the same answer. So that first step of this process to find the optimal bundle is always the easiest. So that's the slope of the budget constraint. Now I need to, my goal in the second step is to find an expression for the marginal rate of substitution. In order to do that, I need to find the marginal utility of the two goods in the utility function by using the power rule. So here was the utility function that I was given. U equals C to the 0.4, F to the 0.6. I first applied the power rule with respect to C. I brought down the 0.4 from the exponent and then reduced the exponent by 1, so you get 0.4 C to the negative 0.6. Since F is not the variable, we just left that whole thing alone, so you get F to the 0.6. I simplified the negative exponent by bringing the C down into the denominator, and so you get the marginal utility of close is 0.4 F to the 0.6 over C to the 0.6. Then I applied the power rule to the utility function with respect to F for food. Same deal with the power rule, brought down the 0.6 exponent in front, and then reduced the exponent on F by 1. So you get 0.6 F to the negative 0.4 C to the 0.4. Again, simplified the negative exponent and got the marginal utility of food right here, 0.6 C to the 0.4, F to the 0.4. So the marginal rate of substitution, so now I'm up here, is the marginal utility of the horizontal good over the marginal utility of the vertical good. Up here at the top, at the beginning of the problem, I decided that F was going to be the horizontal good. You had to decide that to do the slope of the budget constraint to figure out which one was Px and Py. If you define it the other way around, you put C on the horizontal and F on the vertical, you should get the same answer. You'll just end up having your slope of the budget constraint should have been negative 5/2, and then you'll get the reciprocal of our marginal rate of substitution. Either way you set up the problem is fine, as long as you're consistent with how you do it. Anyway, okay, so I plugged in the marginal utility of food up here, and divided it by the marginal utility of clothes right here. I simplified. When you divide a fraction by another fraction, you take the reciprocal and multiply. And we get some nice cancellations again. 0.6 C to the 0.4 times C to the 0.6. You add the exponents together here. You get C to the first power, which is nice. So you get 0.6 C to the 1 over 0.4 F to the 1. And then when you do 0.6 divided by 0.4, that's where the 1.5 C comes from. So the marginal rate of substitution is 1.5 C over F. Okay. So now that we figured out the slope of the budget constraint and the marginal rate of substitution, we're going to set those equal to each other in step 3, which is what I'm doing here. So 2/5 was the slope of the budget constraint. The marginal rate of substitution was 1.5 C over F. I just cross-multiplied and then solved for F and get F is equal to 3.75 C. That's what I'm going to use in the final step to plug into the budget constraint. So we had $30 to spend, clothes cost $5, food cost $2. I substituted in, 3.75 C here, because that's what I got from step 3. And then I just combined and solved and got that C star is 2.4. And then you can either plug 2.4 back into the budget constraint, or you can plug it in here. Which is what I did. 3.75 times 2.4 gives you that F star should be 9. And so that's how you get that solution. All right. If you have any questions, bring them to class. Talk to you later.